So good everyone, you're welcome back to Learn Math. Today we're going to continue with differentiation. But this time around we're going to be looking at quotient rule and chain rule, right? Let's look into quotient rule. Now for quotient rule, you're going to have functions like this to differentiate. Let's say this function y equal to u v. You can see this is a fraction. We have a function above and a function below, the numerator and the denominator, right? So if we are to differentiate this kind of function, what do? We apply quotient rule. Now this is what quotient rule looks like. The differential, that's dy dx, right? The differential of this function is equal to v du. You know what v du mean, right? We're going to multiply v, that's the denominator here. You multiply v with the differential of u, that's the numerator, right? You multiply v with the differential of u minus u dv, right? Now we are multiplying u with the differential of v, right? Multiplying u with one above with the differential of v below over v squared. That's the downward square. We are not differentiating v here, just v squared. This is the formula for quotient rule. V du minus u dv over v squared. Alright, so we're going to take this example under quotient rule, right? Differentiate this function y equals to 3x squared over x cubed plus 2x, right? Now we have numerator, denominator. The numerator, which is our u in this case, you know we have uv. Our u here is 3x squared and our v is x cubed plus 2x. Get the point? These are u, these are v. So how do we differentiate this? We're going to apply quotient rule. So this will be the solution. dy over dx, that's the differential, is equal to u dv, right? We multiply, v du, right? We multiply v with the differential of u. So what's our v? uv. What's our v? This is our v, right? So let's multiply this v. That's x raised to the power 3 plus 2x. Let's multiply this with the differential of u, right? We multiply v with the differential of u, v with the differential of u. So what's the differential of u? 3x squared. That's going to be 6x, right? 6x, that's 2 times 3, 6. Then 2 minus 1, that's 1, right? So the differential of 3x squared is 6x. Now we've gotten v, and we've gotten the differential of u. We're going to subtract u now, dv. So what's our u? This is our u, right? 3x squared. And we're multiplying this u with the differential of v. So what's the differential of v? What's the differential of v? uv, right? What's the differential of v? The differential of v is going to be 3x squared plus 2, right? If you multiply this 3, let's see how we differentiate this to get this. Multiply, you know the quotient of x raised to the power 3 is 1. So 3 times 1 is 3. Then this power of 3 minus 1, that's 2, right? So the differential of x cubed is 3x squared. How about the differential of 2x? Differential of 2x. The power of x here happens to be 1, right? So 1 times 2 is 2. Then you subtract 1 as usual, that's 0. 1 minus 1, 0, right? So since we have x raised to the power 0, x is gone. So we are left with 3x squared plus 2, right? Over v squared. V squared. What's our v? uv, right? uv. This is our v. So we're going to square this. This is x raised to the power 3 plus 2x. Everything squared, right? This is v squared. Now we have just applied quotient rule. That's v du minus u dv over v squared. But let's simplify further. Alright, so simplifying further, we're going to open these brackets and see where we arrive. Now, to open these brackets, we multiply 6x with x raised to the power 3, right? You multiply 6x with x raised to the power 3, also multiply 6x with 2x to open these brackets here. Alright, so this is going to be 6x raised to the power 4, right? Plus 12x squared, right? 6x raised to the power 4, this is 3, this is 1, that's a total of 4. Then 6 times 2, that's 12. X times x, that's x squared, right? Now let's open these other brackets here. Let's open this bracket. Now we're going to have 3x squared times 3x squared. Okay? 3x squared times 2. We're going to multiply this with this, multiply this with this. Okay, before I do that, I'm going to open this bracket with this negative sign. So this is now going to be negative 3x squared. I'm now opening this bracket. Alright, so opening this bracket, we'll have negative 3x squared. Right? Negative 3x squared multiplying 3x squared, not negative. And also multiplying 2. We use this to multiply this and this, right? So now let's open the bracket. Negative 3x squared times 3x squared. What's that going to give us? Negative 3 times 3. That's 9, right? Then x squared times x squared. That will be x raised to the power 4, right? So negative 3x squared times 3x squared is negative 9x raised to the power 4. How about negative 3x squared times 2? What would that be? Negative 6x squared, right? Since 3 times 2 is 6, so we're going to have negative 6x squared. Now that's for the numerator. Let's see what we have at the denominator. Now we have x raised to the power 3 plus 2x, then bracket, everything is squared, right? You can decide to leave your bracket that way, or you might as well want to expand it. If you are going to expand it, you have x raised to the power 3 plus 2x multiplying itself again, since we have squared there. So we multiply this in two places. X raised to the power 3 plus 2x, right? So let's look at the numerator. Let's see, is there any term we can put together? Dividing x is equal to, is there other terms we can put together? Okay, we have 6x raised to the power 4, and we have minus 9x raised to the power 4. So this x raised to the power 4, this x raised to the power 4, I think we can put them together, right? So 6 minus 9, that's negative 3, right? So we have 6 minus 9 x raised to the power 4. The resulting value is going to be negative 3 x raised to the power 4, right? Now we have 12 x raised to the power 2, and we have minus 6 x raised to the power 2. What's going to be the resulting value? 12 x raised to the power 2 minus 6 x raised to the power 2. We'll be left with just 6 x raised to the power 2. Since 12 minus 6 is 6, right? 12 minus 6 will be left with 6. That's for the numerator. Now let's expand the denominator. We'll use this to multiply this, use this to multiply this, then this to multiply the two of them as well. So x raised to the power 3 times x raised to the power 3. What's that going to be? X raised to the power 6, right? X raised to the power 6. How about x raised to the power 3 times 2x? That's going to be 2x raised to the power 4, right? This x raised to the power 3, this x raised to the power 1, a total of x raised to the power 4. Now we've used this to multiply this and this. Let's use the second term here to multiply this and this as well. So 2x times x raised to the power 3, what's that going to be? 2x raised to the power 4 once again. Then finally, 2x times 2x, that's going to be 4x squared, right? 2 times 2, 4, x times x squared. So this is supposed to be the final answer, but let's see if we can put some terms together. Alright, so finally, dy dx is going to be equal to 6x squared minus 3x raised to the power 4. That's the numerator I just rearranged, right? Then the denominator is going to be x raised to the power 6 plus, this is 2x raised to the power 4, this is 2x raised to the power 4. That is the total of 4x raised to the power 4, right? You have 2 here, you have 2 here, that is the total of 4. 4x raised to the power 4s, right? So finally plus 4x squared. So this is the answer, this is the differential of this function. That's the differential. So this simply I apply quotient rule, v du minus u dv over v squared, right? V differentiate u minus u differentiate v over v squared. That's how you apply quotient rule. So now let's move on to chain rule. Alright, so for chain rule, we're going to be dealing with functions that involve more than one kind of function. Okay, before we get to that, let me explain to you that we have different kind of functions in mathematics, right? Now you see this kind of function, we have been dealing with something like something like y equal to 2x squared plus 5 and so on. This is a polynomial function, right? The polynomial function. How about the function like this? Y is equal to log x This is a logarithmic function, right? Then we have y equal to, let's say, cos x, okay, this trigonometric, right? We have even exponential function. We also have exponential function. Let's say y equal to, 5 raised by x, something like this, 5 raised by x. Since it has the power of x, it's now an exponential function. So these are like the kind of function we have in mathematics. So chain rule now is going to be having a function that doesn't contain just polynomial, like we've been dealing with. You may see polynomial and logarithmic, or polynomial, trigonometric, you may just, they will be mixed up, right? So let's take this example, this first one, y equal to x squared minus 5x raised by 3. Now this is a polynomial function inside an exponential function, right? An exponential function. A polynomial function inside an exponential function having an exponent of 3, that is the power of 3, right? How about the second one, y equal to sine 3x squared. Now this is a polynomial function inside a trigonometric function. Get the point? So let's start with the first one. Let's differentiate the first one using chain rule. Alright, so the first one, we have that y is equal to x squared minus 5x raised by 3. Now this is the first step we take. The function, the innermost function, that's the one inside the outer function, which in this case is the polynomial function. You make it a letter, right? Equate it to a letter. Let's use u, right? Let u, we are using the letter again this time around. Let u be equal to the innermost function, the inside function, right? Let u be equal to x squared minus 5x. Do you understand? If u is equal to x squared minus 5x, that means that y is going to be equal to u raised by 3, right? Since you say let u be equal to the inside function x squared minus 5x, automatically y is going to be u raised by 3. So we're going to differentiate these two functions we have created by just assuming u to be this. We're going to differentiate the two functions and then multiply our answers together to find the final y dx. Alright, so if I'm to differentiate this first function now, what am I going to have? Du over dx, right? Because I'm differentiating u with respect to x, right? While here I'm going to have dy over du because I'm differentiating y with respect to u. You understand? Alright, so to differentiate this function, we're going to have 2x, right? 2x. Since 2 times 1 here is 2, then 2 minus 1 is 1, right? Minus 5, right? The differential of 5x is 5. This is 1, right? 1 times 5, 5. Then 1 minus 1, 0. So this is 5x. We have differentiated, we have found du dx, right? Now let's find dy du. This is going to be equal to 3u squared. 3 times 1, that's 3. 3 minus 1, that's 2. 3u squared. Now we have gotten du dx and we have gotten dy du. But this is not what they asked us to find. They didn't ask for du dx or dy du. They're asking for dy dx, right? Dy dx. Now let me show you something. If you multiply du dx, if you multiply this with this, dy du, right? If you multiply this differential with this differential, you're going to get dy dx out. Now this is du dx, right? This is dy du. You observe that du we cancel du, right? Leaving you with dy dx. So to get this dy dx, to get dy dx as the differential we're finding, let's multiply this with this, right? Let's multiply this with this. Now we're going to multiply 2x minus 5 with 3u squared. Alright, so multiplying du dx with dy du, we're going to have this, right? So finally, dy dx is going to be equal to, let's say 3 times 2x, that's 6x, right? Then 3 times negative 5, that's negative 15. So we're going to multiply this with u squared, right? 3 and u squared. So this u now, you remember when we said that the u, the value of u should be equal to x squared minus 5x, right? We're going to substitute this value for u, that's x squared minus 5x, into this u we have it here. So that's going to give us this, the y, the x equal to 6x minus 15 times x squared minus 5x, right? Since our u is x squared minus 5x, now this is u squared, so we're going to be having square here, right? So this will be the answer for the y dx. You can decide to go further to open this bracket. Okay, if we are to open this bracket, this is what we have. 6x minus 15 multiplying x squared minus 5x, still multiplying x squared minus 5x. Because this square, u squared, right? We're going to have it in two places. So you open these brackets, you get your final answer. Alright, and that will be it for chain rule. I'll see you in the next video where we'll be talking about differentiation by first principle. So till then, please do well to like this video, subscribe to this channel. Goodbye.